All right, just a very quick addition to this. You see what I have tried here. I did this years ago, but what I see is a nice pink vase that I got from my wife a few years ago, and a tank. All right, we used to have a fish or some sort of animal in there. Now, this is actually a circular, what? It's a circular hyperboloid if you look at this, all right? But in order to illustrate what's happening with the hyperbolic paraboloid, it's basically the same thing. So I will show you what's happening here. It's going to just take you a few minutes, all right? And so what I'm doing here is putting this on the side and then just fill this with a garden hose, right? Very, very basic thing. I mean, I could do this much cooler with, sort of an electronic device like a graphing calculator. And you too can do this on your graphing calculator or a 3D graphing app if you download, such as Good Grapher, okay? And what you can do is draw these or write equations down on these, program these equations on your Good Grapher or other apps. Desmos, GeoGebra probably do the same thing. And then you also draw the planes like z is equal to 0 or z is equal to 5 or z is equal to -4 or something and see what the cross sections look like. But, we have this thing called gravity. And, surface of the water is basically your horizontal lines. These are the z is equal to -1, -2, 0, 1, 2, and so on. Okay, so you see the water coming in to this tank and see this is a side view. The water is keep coming in. I'm taking pictures. What's going to happen here? See, this is like your saddle point right here, right? So this is the minimum point if you're going this way. It's a maximum point if you're going to cross this way. So it's a saddle point, just like what you see in a hyperboloid or a hyperbolic paraboloid. This is a circular hyperboloid, but this really is a saddle point. And so what happens as you pour water in, now, do you see a hyperbola? Okay, yeah, that's the hyperbola you saw when z is negative in that hyperbolic paraboloid. Okay, so z is negative, and so you're seeing this, and right here is a saddle point, which is where the origin was, z is equal to 0, and you see hyperbolas. In fact, the hyperbola get closer and closer and closer, right? You see that? I mean, this is a hyperbola. Okay, now remember, this is basically the cross section. It's like where you cross that the saddle or the hyperbolic paraboloid where z is equal to -1 or something. Okay, it's the z value or the water surface is very close to this point in the middle, which was our saddle point, right? Now it gets really close, really close, really close. This is like less than an inch now. Okay, what's going to happen in the next one? Well, according to our calculation, when z is equal to 0, this gave way to what? 2 lines, right? Basically, what you saw when z is equal to 0 is this line here and this line. It's degenerated, the hyperbola degenerated into 2 lines. All right, but of course, it's really hard to show that moment with a garden hose. And in fact, because water has tension, it creates something different. Now you watch what happens after this. Immediately after this, I keep adding water. What's going to happen? Can you picture this? Well, it's still there, really close, all right? And then it becomes the 2 lines. And then in the next moment, they touch each other, okay? So the hyperbola used to be this one and this one. You see, I changed the orientation of this, right? Hyperbola used to be this and this. Now, because they touched each other, almost like kissed each other, now you see this other hyperbola in the different orientation. See that? All right, that's what's happening. And then, of course, if you keep adding water, the new and different orientation hyperbolas get farther and farther apart, all right, as you get more water to it. So that's what's happening with this, right? Again, at the beginning, it was this parabola, top and bottom, and then it became 2 lines, and then it became this other parabola. Okay, and that's what you are seeing as you looked at these traces where z is certain constant. Okay, and as I said, I said that this is really a favorite. This negative curvature surface, such as hyperboloids and hyperbolic paraboloids, you see this in different places. And one place you see this in is a museum in Paris, where you have a circular hyperboloid as a centerpiece because people find this beautiful. All right, on that beautiful note, I will see you, and I can't wait to tell you more about beautiful things in calculus. All right, have a great day. See you later.